All right, y'all. So for this video, we're going to just review factoring and the quadratic formula and how to find solutions with both of those. So page 4 in your packet, we're going to start with a review of factoring to find solutions. So the first thing that you're going to have to do is obviously factor it. And then when you get those factors, remember you'll set each factor equal to 0, and then you'll solve for x, all right, or p, or just whatever variable you have. All right, so if we look at this first example, this is an example of the AC method. So you're going to multiply 1 times negative 14, and then that's your A times C. So you get negative 14, and then you've got to figure out, well, what can you multiply to get negative 14 that's going to add together to give you the negative 5 that you need in the middle? And so you would use negative 7 and positive 2. Now, because A is 1, you can go straight to your parentheses. So we're going to have x minus 7 and then x plus 2. Now, because we're solving, we're going to set that equal to 0. So then you would take each of those factors and set them equal to 0 and solve for x. So you would have x minus 7 equals 0 and x plus 2 equals 0. So I'm going to add 7 to both sides. To get 7, that will be one of my solutions. And then for the other one, I would subtract 2 from both sides to get x equals negative 2. All right. The second example is a difference of squares problem. And so that one, we can pretty much go straight into our parentheses because the square root of 64 is 8, except we need a negative 64. So that means we're going to have a positive 8 and a negative 8. So we're going to have x plus 8 and x minus 8. Now, because we're solving, remember we set it equal to 0. So we'll say x plus 8 equals 0 and x minus 8 equals 0. So we'll subtract 8 from both sides to get negative 8, and then we'll add 8 to both sides to get positive 8. All right, so I'm kind of going through these a little quickly because we've already done a lot of factoring. We've factored in Unit 1, we factored, pretty extensively in Unit 1, but now we need it for Unit 3, so we just need to do a quick review. All right, so the third example is the AC method. All right, so 6 times negative 3 is negative 18. All right, but we need to figure out what can we multiply to get negative 18 that's going to add together to give me a 7 in the middle. So we would have positive 9 and negative 2. All right. And so we're going to replace 7x. So remember, we can't go straight to parentheses here because A is not 1. So we're going to have to keep the 6x squared, but 7x is going to get replaced with a positive 9x and a minus 2x. And then we also have a minus 3. All right, so this is the type of problem where we have to do grouping. So we're going to split it down the middle and do a GCF on the left and a GCF on the right. So on the left, our GCF is 3x. So that gives me 3x times 2x plus 3. And then on the right side, there's not really a GCF, but we have to factor out something. And because they're both negative, we're going to factor out a negative 1. So when we factor out the negative 1, we're left with a positive 2x and a positive 3. So remember, when you do this process, the parentheses should match exactly, and they do. So that's a good clue that we've done it properly. So we keep that one time, and then whatever's left over, 3x and a minus 1, that gives us our other factor. So now that we've factored it, now we can set it equal to 0 and solve for x, because we need our actual solutions. Remember, solutions are also called roots, zeros. They represent the x-intercepts on a graph. All right, so we're going to say 2x plus 3 equals 0 and 3x minus 1 equals 0. So for the first part, we would subtract 3 from both sides. So 2x equals negative 3, divide by 2, and we get negative 3/2. So one of our solutions is negative 3/2 or negative 1.5. All right, for the second one, we're adding 1 to both sides. So 3x equals 1, divide by 3, and x is equal to 1/3. All right, so two solutions there. The fourth example is another example of the AC method where A is not 1. All right, so A times C is -6. So -6, and then we got to figure out what can I multiply to get -6 that will add together to give me the 1 that I have in the middle. And it would be a +3 and a -2. So I'm going to keep the 3x squared, but I'm replacing the 1x with a +3x, a -2x, and then I still have a -2. So again, we had to do grouping because A was not 1. So now we're going to split it in the middle. A GCF on the left is 3x. So that leaves me with a 1x and a +1. And then on the right side, we're going to factor out a -2, which leaves me with a +1x and a +1. So again, my parentheses match, which that's what we were aiming for, right? So we have x + 1, and then we have 3x - 2 left over. So we're solving, so we're going to set equal to 0 and solve for x. So x + 1 = 0, and 3x - 2 = 0. So x + 1, we'd have to subtract 1 to get -1. So that's one of my solutions. So remember, this represents, if we were to graph this, our graph would cross the x-axis at -1, but it would also cross at this other one. So we're going to add 2 to both sides. So 3x = 2, and when you divide by 3, x is equal to 2/3. So our graph would also cross at +2/3. All right, so that's a quick review of factoring. All right, so you'll have the practice to do at the bottom of the page, so you'll do those. And then when you flip over to page 5, this is a quick review of the quadratic formula, because the quadratic formula is also something that we use to find solutions. So remember, when we find these solutions, it's the same thing as a root, it's the same thing as a 0, and they represent the x-intercept on a graph. So the reason why we're doing this is because in the next lesson, you're going to have to find all the different roots, but we're going to be dealing with functions of much higher degrees. And then we're also going to be eventually graphing these polynomial functions. And then one of the characteristics is, where does the graph cross the x-axis? You're going to have to identify these roots, these zeros, these x-intercepts. All right. So for this first example, the quadratic formula is up here, so you have that. There's also a reminder or refresher on here about the discriminant and what the discriminant means. All right, but I'm going to jump right into the quadratic formula since this is a review. All right, so the first thing I'm going to do is identify my A, my B, and my C. So A is 4, B is -2, C is +9. So when I substitute into this formula up here, the quadratic formula, I'm going to have x equals opposite b, so that's going to become +2 plus or minus the square root of b squared, so -2 squared minus 4 times a, which is 4, times c, which is 9, all over 2a, so 2 times 4. So I'm going to break this apart a little bit. I have 2 plus or minus the square root of something over 8. So this is where my calculator comes in, and I'm going to use the discriminant portion, which is under the radical. All right, and I'm going to put in my calculator -2 squared, make sure you use parentheses, minus 4, okay, not -4, but minus 4 times 4 times 9. And I got a -140. All right, so -140. All right, now because we have a negative under the radical, we know that we're going to be dealing with an imaginary number. So I can find the square root of a +140, which is 2 square roots of 35. But because it started out negative, I have to remember to pull out an I. All right, so I'm going to rewrite this as 2 plus or minus 2i square roots of 35 over 8. And then the last thing that I'm going to do is simplify. And the reason why this one can be simplified is because 2, 2, and 8, all three of those terms are divisible by 2. So when I reduce that, it's going to be 1 plus or minus 1i square roots of 35 over 4. And you could break it apart, you know, where you have 1/4 plus or minus the square root of 35 over 4i. But this is plenty fine. Okay, but what you would want to know about this particular function, because we're talking about solutions here, is we have two imaginary solutions and we don't have any real solutions. So what we know about this graph is it's never going to cross the x-axis. All right, so another example, the second one, a is 3, b is 4, and c is -8. So when you substitute into the formula, opposite b is -4 plus or minus the square root of b squared is 4 squared, minus 4 is part of the equation, a is 3, and c is -8. All over 2a, so 2 times 3. So we have -4 plus or minus the square root of something over 6. All right, so in my calculator, I'm going to type in the discriminant portion. So I have 4 squared, make sure you use parentheses, subtract 4, parentheses with a 3, parentheses with a -8. And we get positive 112. All right. Now, there's a couple of things that you can do with this. All right. Now, you could simplify the square root of 112. All right. But you may also want it as a decimal. So it really just depends on the format that you're looking for. All right. So I'm going to kind of show you both. All right. If I did the square root of 112 in my calculator, I get 4 square roots of 7. So this would be -4 plus or minus 4 square roots of 7 over 6. Now, -4, 4, and 6 are all divisible by 2. So I could reduce that and I would get -2 plus or minus 2 square roots of 7 over 3. All right, so that's one way that I could write it if I wanted to reduce my radical. All right, but if I'm looking at graphing, like this is an exact answer, right? There's nothing rounded or anything like that, okay? But if I wanted to actually see, well, where's it going to cross my x-axis, then I might be more interested with a decimal answer. All right, so I'm going to kind of show you that instead. So if I wanted a decimal, all right, I'm going to kind of decimal, then I need to do this problem twice. I need to do it once where I add, once where I subtract. So in my calculator, I'm going to use the n over d button right here. And I'm going to say -4 plus the square root of 112 over 6. And I'm going to, I get something kind of weird, but that's okay. I'm going to hit double arrow down here at the bottom, and I'm going to convert it to a decimal. So when I added, I got 1.097. So that would be one of my solutions. Now I'm going to do it again, n over d, -4 minus this time the square root of 112 over 6. I'm going to hit double arrow again to get the decimal, and I get -2.431 if I round it. All right. So it's not that I'm getting two completely, different problems here. Like, I mean, I don't want you to think that this is an answer and these are an answer too. These two answers are actually equivalent to this. It's just this is my exact answer, and these are the actual decimals where it would cross the x-axis. So if I needed to really know, like, well, what exact point over there, if I needed to plot a point, then these would be the decimals that would help me do that. But this is the exact answer. All right. So one last example. So on this last example, remember, if there's not a number in front, if there's not a coefficient, it's 1. So A is 1. B is -5, and C is +9. So when I substitute into my formula, opposite B is +5 plus or minus the square root of B squared is -5 squared. Make sure you use parentheses because especially when those negatives, it matters. -4 times 1 times 9 all over 2 times 1 this time. So we end up with 5 plus or minus the square root of something over 2. So again, in my calculator, I'm going to type in the discriminant portion. So I'm going to have -5 squared, make sure you use parentheses, -4 times 1 times 9. And I got -11. All right, well, this is another example of an imaginary solution. All right, so, but this time, if we did the square root of 11, it doesn't reduce, right? So that's okay. We still pull out the I, but we leave the 11 under the radical because it never got to come out, okay? It does not simplify. So this answer then would be 5 plus or minus I square roots of 11 over 2. And those are my two solutions. 2 because I have a plus and a minus. Now they're imaginary, so what that tells me about my function is it's never going to cross the x-axis. All right, so that at least helps me make a prediction about what my graph will actually look like. All right, so the reason why we are reviewing solving with the quadratic formula and solving by factoring is because in the next lesson, you're going to be having polynomials that have a much higher degree. Like you may have something to the 6th or 7th power. Well, you can't just factor it. So we're going to have to use something called the rational root theorem that's going to help us figure out some of our factors. But then we're going to get to a point where our factors may not be whole numbers, okay? Or our solutions, our zeros may not be whole numbers. And then we're going to get to a point where we're going to have to solve it and potentially use the quadratic formula or factor it or, some other methods. All right, so that's why we're reviewing that. So now you have some additional practice to do at the bottom of your paper. And then the next lesson, we'll get into the rational root theorem.